Yes, sir.
Yes, sir.
Thank you very much. Good evening, one and all. I am Dr. Muhammad Sirajuddin, co-coordinator of this 6 days faculty development program. I welcomes you all to the day fourth of this online FDP. Now, I take privilege to invite our eminent speaker of today's session, Mr. Ranjit Kumar sir. Mr. Ranjit Kumar sir is an accomplished IT professional with over 17 years of experience in software development, in DevOps practices, and IT infrastructure management, with a proven track record in designing, deploying, and managing the scalable enterprise applications. And he has consistently contributed to streaming development of pipeline applications, and he also expertised in DevOps automation, CI/CD implementation, various cloud platforms, and so on. He's also expert in agile methodologies and makes him a versatile asset in the IT industry. I welcome you, sir. Please over to you, sir. Ranjit Kumar, sir.
Thank you so much, sir. Thank you very much. Hi, good evening, everyone. I'm audible.
Good evening, sir. Your voice is very clear. PPT is
Yeah.
also visible, sir. Please carry on.
Yeah. Okay. Good evening to one and all. Today, our session is on quantum cryptography in an action to build the digital world. Now it is moving towards a past classical methods to an encrypted method, which is nothing but before we are using classical computers. Now we are moving to the quantum computers. It is nothing but an evolution. In the earlier days, we used to having the Pentium 1 systems. It is nothing but it has a very large transistor chips. And next we have the updated to the Pentium 2, Pentium 3, Pentium 5. So all these are nothing but we are adding the chips, n number of chips into the processor. Every computer must need a processor. For that processors, we need an transistors. Initially, it is a big processor and it has only few transistors to transform the signals. And after Pentium, we have the Intel 1, Intel 2, and AMD processor. Now we are using AMD processor. But our in digital era, we are moving to the very miniature. It is nothing but everyone is becoming a nanotechnology. We are using nanotechnology. For that, we are in computing, we are going to use quantum technology. This is nothing but with the help of the photons. It has an n number of transistors in the module, nothing but a chip. The chip consisting of an n number of chips. Why? With the help of the chips, we can able to process the data. Initially, we have the 8-bit processor. Next, 16-bit. Next, we have 32-bit. Now we are using 64-bit. But with the help of the quantum technology, we can able to use n number of bits. It has a huge number of bits. Recently, IBM has launched its quantum system. It has an 400 bits. When compared to the 400 bits is nothing but billions of data can be transmitted within a second. We can able to transfer the billions of data. Why? Because in our system we will use only the now we are using present 64 bit, but it is a consisting of an n number of bits. It's going on increasing from day 1 to day 2 daily. Present IBM has launched its 400-bit processor, nothing but a 400-bit processor. It can able to solve the very huge complex problems. With our system, we can able to solve the problems, but we can't able to solve the problems like complex problems like in chemical industry. In a chemical industry, there are huge number of molecules there which has to react with each other to form the chemical bond. That type of problems we can't able to solve by with the help of our traditional system. But with the help of the quantum systems, we can able to solve all those problems. Here in traditional system, we have only the either one, either zero. It is nothing but if it is on, it is one. If it is an off, it is zero. It is nothing but an transferring the signals to the chip by using the electromagnetic waves. We will pass the signals, either it may be one or a zero. We will use only the binary bits. It is nothing but either one or zero. But coming to the quantum, it has one, zero, and combination of the both one and zero simultaneously. Like when we are tossing a coin, suppose if we toss a coin, it has an one, zero, nothing but if it is an head, it is an head is nothing but one. If it is an tail, it is zero. But in between, it has a probability for the one or zero. In between, when we are tossing a coin, it has the two probabilities. One is heads, one is tails. But before the result, it has the n number of possibilities. Either it may be head, tail, tail, head. Like that processes we have. It is nothing but if it is an upward position, it is called as a one. If it is a downward position, it is zero. If it is in between the n number of possibilities, either one, zero, zero, one. It is nothing but the quantum bits. If the position is upwards, it is called an 1. If the position is downwards, it may be 0. If it is in between 1 and 0, it may be either 1 state or 0 state. It is called as an superposition state. It may be in a superposition state like 1 0 or 0 1 1 0 0 0. Like n number of probabilities are there. And if there is a combination of 1 and zeros, there is also one more combination called 1 and zeros. It is nothing but an entanglement. It is called as an entanglement for 1 and 0. Two quantum bits can be combined together and form an entanglement. These are some of the basics which we are using for the quantum computing. Now our coming to our topic, we have some cryptography, which algorithms they are using and how they were encrypting the data with the help of the quantum. It is nothing. Coming to the slide, sorry. Coming to our session, we will have the fundamentals of quantum cryptography and real world applications across the different sectors and building the quantum secure networks and implementation of the roadmap and further outlook and strategies. We will, in the first session, we will have about the core principles and key technologies of the quantum cryptography. And next, we will deal with the real-time world examples like an government sector, health sector, and financial sector, how it will be used in the government and financial health sectors. Next, we will discuss about the different types of networking technologies like QKD network technology, hybrid technology, and which infrastructure it is using. Next, what is the roadmap to develop the quantum computer? What is the roadmap we are going to use? Next one, future outlook and strategies. Which strategies they are going to implementing for to success in the quantum computing. We have the four principles of the quantum cryptography. One is quantum uncertainty. Next one is the quantum entanglement. Next one is no cleaning theorem. And fourth one is the superposition. Here, quantum uncertainty is nothing but which will using the physics concept, which we are used in the physics during the intermediate or degree. No, we will have the some Heisenberg uncertainty principle. It will use the same principle. Just if someone want to measure the which state in the quantum, if either it is in upward position or downward position, we will make the use of the quantum uncertainty. Example, let's think like that. If you are trying to measure a soap bubble, if you want to measure the size of the soap bubble, the act of the touching it pop hits. Similarly, the about the distribution quantum states, how it distribute the quantum states, like like of a measuring of a soap bubble. Next one is the quantum entanglement. Entanglement is nothing but the if either is a one position or zero position in between there is a one and zero, it is called a superposition. If it is a combination of the pairs, it is a pair of the particle may be possible during the processing the signals. It is called as a quantum entanglement. Here, let us take the two particles are linked, and no matter how much distance it in between them, if there is no matter of the distance in between the two quantum particles, they may be communicate with the each other independent of the distance. And next one is no cleaning theorem. No cleaning theorem is nothing but we can make a perfect copy. We can make the perfect copy of an unknown quantum states. If you don't know the state of the quantum, then we will use the no cloning theorem. With the help of that, we can find the which state. It may be in same state or another state. We can find with the help of the no cleaning theorem. For example, unlike a photocopying a document, if you are photocopying a document, a quantum key cannot be duplicated. Quantum key cannot be duplicated. While we are photocopying a document, a quantum key cannot be duplicated. Next one is the quantum superposition. Here superposition is nothing but a quantum particle can be in multiple states. Quantum particle can be in multiple state at once until it has measured. If you measure the distance of the particle, it may be in the same position or multiple position states. Like Schrodinger equation, we will use the Schrodinger equation. Either it may be a live particle or a dead particle until we look into the quantum. And next one is the cryptographic techniques. Which techniques they are using? We are using mainly the three quantum techniques. One is quantum key distribution, and second one is the quantum random number generators, and third one is post quantum cryptography. With the help of these three cryptography algorithms, they are developing the quantum systems. We cannot track these systems. Why? Because there are n number of keys when we are passing the signals. One is the quantum key distribution. First one about quantum key distribution. It is used for the secure communication method. We will use quantum QKD for the security purpose for communication, for securing the communication. That uses the principles of quantum mechanisms to share the encrypted key between two pairs. It is used to share the encrypted key between two pairs. It is nothing but an Alice and a Bob. In quantum, we will call as an Alice and Bob. Here, Alice is nothing but a receiver. One is transmitter. One will act as a receiver. Another one will act as a transistor. Unlike our classical cryptographies, in our classical cryptography, it is not present, which relies on mathematical complexity. Which has a mathematical complexity. We will use QKD for leverage the law of the physics. With the help of the law of the physics, we will develop it. It can be possible by the mathematical, making it as an unbreakable by theoretically and practically. We can't break it by theoretical or practically. It is not possible for hack the QKD algorithm. Why? Because it has using the physical laws, not the theoretical laws. It will be use the physical laws. And QKD allows the user to share a secret random key. It will be share the secret random key that can be used for the encrypting and decrypting of the messages. While we are using the QKD algorithm, allow the two users. It will allow the two users to generate a shared key between the receiver and transmitter. Then with the help of that key, we can able to encrypt and decrypt the messages. It is a security for guarantee. It